Day 144, Physics, Circuit 1A. In these problems, bottom line is, here are all the concepts up here at the top. The idea is, as you solve these problems, what I first want you to do is to draw the simplified diagrams, and you'll be applying these two rules for combining resistors, whether they're in series or parallel, remembering that in parallel, when you have multiple pathways, all the voltages are equal. For example, in this case, there are two pathways. If I label this point right here, point A, and this point over here, point B, there are two ways to get from A to B. You can go straight across from A, across the 20 ohm resistor to get to B, or you can go from A up and around that pathway. Most electrons will pick this pathway because there's half as much overall resistance, 20 ohms, versus the 40 ohms up there. Mathematically, bottom line is twice as many electrons will go here as here, because it's twice as hard to go through that pathway. Not just because it's a long pathway, that has nothing really to do with it, it's because it's got a 40 ohms of resistance. So, some of the other things, once again applying the basic principles, is that then this resistor is in parallel with this combination up here. These two are in series with each other. They're in one pathway, so those a 10 and 30 ohm resistor are in series. They will have the same current as each other. So here's what you'll be doing. In this case, drawing diagrams, usually 2 or 3 extra diagrams. And there can be more complicated circuits where you have to draw 7 or 8 diagrams. We're not going to get to those, or even more. But in this case, you add the 10 and the 30. They're in series, and there's no rule that says you always start with the series part of the circuit. You'll see that as we go along with the examples. It depends on the circuit whether you start with a series or parallel portion. But in this case, it should be fairly obvious that the 10 and 30 are in series. The simple way to combine those two resistors is just to simply add them. 10 plus 30 is 40, and then draw the new diagram. So in the interest of time, I drew both diagrams. I drew the intermediary diagram where I added the 30 and the 10. I got 40 ohms here. And then these two resistors are in parallel. So I used the rule for combining resistors in parallel, which is over here. 1 over the total resistance equals 1 over 40 plus 1 over 20. So the total resistance is 13 ohms. I rounded off to 2 sig figs. So here's the first progression. Draw these diagrams. On the homework, on the tests, you simplify the diagram so you get down to 1 battery and 1 resistor. I'll have all problems that are solvable like this. It's possible that problems cannot be solved in this manner, but all the ones we'll have will be simplifiable down to 1 resistor, so you'll always get down to something like this. Once you get there, what you need to do is, starting with that simplified diagram, you work backwards, but you will be using the Ohm's law way up here on the left, exclusively working your way backwards. So that's really all we're going to be doing now, is using that equation over and over and over again, starting with that last diagram. So here we have V equals IR, where V is 100. We're looking for I. R is 13. So the current here in this last little diagram is 7.7 amps. That's an important number. We'll save that number for now. What that means is that the battery is supplying 7.7 amps to this circuit. Now, conceptually, once again, the current is flowing everywhere in the circuit. It doesn't start from the battery, but for illustrative purposes right now, let's say it did start at the battery. You have 7.7 amps of current, 7.7 electrons or whatever, but everything's flowing everywhere. It's like musical chairs once again. It all starts up. The wires are full of electrons. But if I started from the battery and went up here towards point A, 7 amps of current, 7.7 amps of current are flowing into there from the battery. I could illustrate that with this arrow. Bottom line, that represents current flow of 7.7 amps into point A. When that current gets there at point A, it has to split, or it will split. Most of the current will flow across this easier pathway from A to B, but some of the current will go up around the 40. Bottom line, as I said before, twice as much current will go this way from A to B as it will through the twice as difficult path, the 40 ohm resistor. Now, a couple ways to figure it out, but the basic way to figure it out is using V equals IR. So I will go to that once again in this middle circuit here that I'm dealing with. I'm going to start with the 20 ohm resistor, and the way I'll depict that is I'll just say V sub 20 for the 20 ohm resistor equals I sub 20 times R sub 20, which means I'm looking at the 20 ohm resistor now. Now the thing is, it does not get 7.7 amps of current. It's going to get some portion of that. But I know it's directly connected to the 100 volt battery, so I know its voltage is 100 volts equals I20 times the 20 ohms of resistance. All right, so if I do the math there, I get that the current in there will be 5 amps, 5.0 amps. And once again, I've rounded off to 2 sig figs, so my numbers will be off a little bit, but that's good enough. 5 amps. So I know that there's 5 amps then from point A going across this way to point B along that pathway. And half as much will go the other way, 2.5 amps, or you can do the math there for that upper resistor. I'll use a different, well, yeah, I'll use a different color, green. So for the 40 ohm resistor at the very top there, I would have V sub 40 equals I sub 40 R40 for that 40 ohm resistor. It's got 100 volts of resistance, or 100 volts of voltage, because they're in parallel. The rule is in parallel they have the same voltage, not the same current. So it's still 100 volts equals the current through the 40 ohm resistor times its resistance, which is 40. If you do the math there, you would get the current through the 40 ohm resistor equals 2.5 amps. Once again, it's a little off. I'll go back to blue. I know there's current going around this way, along that pathway, of 2.5 amps. Now, in a perfect world, the 5.0 plus the 2.5 should have added up to 7.7. In other words, there's 7.7 amps of current going in here. There should be 7.7 amps going across here and around there. So roughly this might be 5.1 and 2.6 or something like that. But they're a little low because I've been rounding off. But they roughly add up to 7.7. In a perfect world, it would be exactly 7.7 amps. So we have 5 amps and 2.2 amps coming back in here. All right. That means that, once again, I'm rounding off, but going back to my original, there would be 7.7 amps coming back around this way, if all added up perfectly. And that's the current flow, which starts up, doesn't start at the battery, it starts everywhere all at one time. Those are the current flows. Now, I have to go back to the first diagram right here. I know in this diagram here from A to B, along that pathway at the top, I have in this, what would be called a branch, or that path, I have 2.5 amps of current. It goes through each of those resistors. They're in series, they're both getting 2.5 amps. And if you said 2.7, that'd be okay, anywhere from 2.5 to 2.7 amps. Because you could have recognized that 7.7 minus 5 is 2.7. So I would have accepted 2.7 amps there. But in those two resistors up there now, I'm going to use Ohm's law. Okay, V equals IR, so say V10 equals I10 R10. And it's not 100 volts now. What I know is that their voltages add up to 100. They do not have the same voltage. But for the 10 ohm resistor, V10 equals 2.5 amps of current times its resistance of 10 amps. So, I'm sorry, of 10 ohms. The voltage is 25 volts for that particular resistor. And then for the 30 ohm resistor, it'd be V30, I'll use green. V30 for the 30 ohm resistor equals I30 R30. Its voltage is going to be the current 2.5 times its resistance of 30. So this actually comes out pretty well, because 30 times 2.5, I believe, is 75 volts. which is nice because what is 75 plus 25? That's 100 volts. So together they're 100 volts. So that came out perfect. So if I would have used the 2.7, I would have gotten a little high. So that works out pretty well. Now we're ready to fill in a table. We could have started filling in a table a little earlier, but I will fill it in now. All these numbers that are important are circled. For example, the 10 ohm resistor that I just figured out, we'll switch to red. The 10 ohm resistor, actually, I'll do red. The 10 ohm resistor has 2.5 amps of current. It has a voltage of 25 volts. And if I wanted to get the power, I would multiply the current times the voltage. It's up here in the upper left. Well, let me fill in all the chart first. The 20 ohm resistor, had a current of what, 5 amps if you look at the table or the circled numbers below. 5 amps of current and a voltage of 100 volts. The 30 ohm resistor has 2.5 amps. Same as the 10 ohm resistor, but 75 volts potential difference or voltage. The battery current was 7.7. If you want to say 7.5, that's fine. Its voltage is 100 volts. All right, now we've got to figure out the power. And what you will do is you can use this equation right here, either equation actually, because this equation right here is a combination of the two upper equations. But if I just take the voltage times the current, which basically is multiplying these two numbers, 2.5 times 25. Actually, the second one's easy because 100 times 50 gives me 500 watts there. The battery is 770 watts. 100 times 7.7. So multiplying these numbers and rounding off to 2 sig figs, the 2.5 times the 25 gives me 63 watts. I'll even round off to, well, I'm going to round off to 1 sig fig just to show you here. 60 watts, and then 2.5 times 75 is 190. Everything's off a little bit because I've been rounding off a lot. But bottom line is, those three numbers, I'll circle them in green, these three powers are the power that's being used by the three resistors. If their light bulbs are giving off light, the brightest light would be the 20 ohm resistor, the 20 ohm bulb. Those three numbers, or wattages, powers, in that green circle should add up to 170. Now they add up, 770, which is the power being supplied by the battery. Comes out to be 750. It's a little low because my currents were a little low, rounded off to 2 sig figs. But it roughly adds up and confirms that we've done the problem correctly.